Now we are going to work on the multiple linear regression. Okay. So what is meant by multiple linear regression? Next heading is multiple linear regression. In the last class, we have completed the simple. Now we are going with multiple. Okay. A regression. Regression means predicting the output variable which is continuous. Predicting output variable which is continuous. Output variable which is continuous. If the output variable is continuous only, we have to apply the regression. What is meant by linear? Assuming the relation between x and y is linear. Again, once again, assumption only. Assuming they are both are linear, our assumption. And what is meant by multiple? Multiple means multiple x values. Multiple x futures are there. Independent futures are multiple are there. Instead of one, multiple are there. That is the difference. Nothing else. In the simple, only one x future is there. In multiple x futures are there. That is with respect to x1, x2, x3, x4. Like this, we are having multiple, more than one. Multiple x futures means more than one x variable. More than one x variables. Then it is called as multilinear regression. Then only we can apply the multiple regression. Whether it is a linear or non-linear, multiple regression. If you apply linear means linear regression. If you apply non-linear means non-linear regression. So here, if you go with the single, you are writing a right. If you are going with the simple linear regression, one simple linear regression, you are having only one x and one y. And the equation is called as y is equal to beta naught plus beta 1 x. And the line will be represented like this, right? Now the same thing, if you go with the multiple linear regression. In the multiple linear regression, you are having more than one x variable, like x1, x2. Two are there and one output is there. Example, let us assume. Now the equation is going to be y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2. It is going to add one more. Sir, when one more added, automatically one more intercept also should add, right? Quotient is added means intercept also has to be added. So logic is correct only. Whenever there is for one variable, this is x1 versus y, this is the line. If the x2 versus y, this is the line. Some different line is there. Now then automatically for x2 different intercept will be there. For x1 different intercept will be there. Slope will be different, intercept will be different, something. Now then how we are going to identify that one is just simple. For example, y hat is equal to, for first variable, variable number 1. First variable, beta naught plus beta 1 x1. Completed. Second variable, beta 2 plus beta 2 x2. Something you have added like this. For the third variable, okay, beta 1 plus beta 1 x1. Oh, beta 1 means again it is going to be confused. Okay, let us take this quotient as intercept as I plus beta 1 x1. This intercept value as j plus beta 2 x2. Value only now. Some j is value. Now third variable. If you are having third variable, k plus beta 3 x3. Now inside that, beta 1 x1, beta 2 x2, beta 3 x3, and whatever the I is there, I plus j I can add, plus k also I can add. Everything is a single value only. That single value is beta naught. After adding everything, the final one is beta naught. Means multiple intercepts are also added in this only. It is not the single intercept, multiple intercept, but all the intercepts are added because that is a single values. Whereas these values are connected to the x1. We can't add beta 1 plus beta 2 plus beta 3 because beta 1 is connected to beta x1 separately. Beta 2 was connected with x2 separately. Right? Whereas intercept is different one. Is that clear? So now here we are going to apply on the multiple linear regression. Right? Now multiple linear regression where first here the multiple linear regression is having with 3 input variables. So now what is the business problem? What is the business problem is you have to identify the relation between each advertising channel versus sales. That is TV, radio, newspaper versus sales. Now you have to bring a equation in such a way, TV, radio, newspaper versus sales equation in that way. Means y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 because 3 variables are there x3. 10 variables are there means up to x10. Beta 10 and x10. Two variables are there, means beta 2, x2. Three variables are there, beta 3, x3. Now what is x1 is TV. What is x2 means nothing but radio. And what is x3 means newspaper. Sir, why beta 1 to be TV only? Because whatever the order I am considering in the training data set, not here. Not in between, you do anything. Whatever the manipulations you want, you do. You bring this one starting position, ending position, whatever it is. Whenever you are fitting the model you are going to fit the data. This x-train, whatever the x-train is there, in that whatever the order of x-train is there, that is the order. The order of the equation will be decided based on the x-train data which is used for the fitting purpose. Okay, here whatever you have to open this x-train. Open this x-train. In this x-train, if TV is in the first position, means x1 is TV. If the radio is in the first position, means then radio will be in the first position. Whatever is there in the first position, that is the first one. Right? So whenever you are executing the code, just in the order, whatever the order you are fitting the data, it is going to create the algorithm also in that way. The equation also will be created in that way. Okay? Because the mathematical equation will be done by assuming this as the data set. To that previous, what is the data set? You have done the cleaning, you have done, the machine will not know all these things. Machine knows only one thing. You have given the x-train like this. Immediately, whatever the data you have given here, whatever the order you have given, according to that, I will process. That's it. And it will apply the data. From where you got this one, you have collected from the website, your friend has given, it will not ask all these questions. Whatever the data you have given, it will fit. Fit means calculate. Calculate means whatever the mathematical equation is there, it is going to apply that mathematical equation. That's it. Is that clear? So here, whatever the order is that order is important for us. Okay. Now, here they're asking the question is between the TV, radio, newspaper and sales. Means there is a client called as X client. Assume that client name is called as Good Boss. Lalita Jewelry manager is there, right? He is the person. Assume. Example. Now he has given that project to the one company. Okay. One X company. Now this X company, what he'll tell, this Lalita Jewelry person will tell that in my particular showroom, I'm selling the different kind of gold ornaments or diamonds or different types of ornaments I'm selling. Now for this, I'm spending the different amount on the TV. I'm spending some amount on the TV, some amount on radio and some amount on newspaper. And these many products has been sold earlier. I have given with respect to, I have spent this much of amount earlier and this much of sales was happened earlier. Now, based on that, in the future data, if I want this much of sales like this, means how much amount I have to invest? That is his question. He is expecting a sales of, for example, 20,000 units has to be sold. For that, how much I have to invest in TV? How much I can invest in radio? How much in newspaper? So that the overall will be less. Instead of investing everything in the TV, I want less. Overall, it should be less. In which way, if I apply that one, I will get 20,000 units get sold. That is my question. And for this, you have to do with maximum accuracy, whatever you can do. They have not given the restriction. So just they are asking with maximum accuracy. Whatever you can do, do the max. This is the data set. That is the requirement of the problem. Now, whatever the problem requirement is there, I'm going to import the NumPy, Pandas, Matplotlib. And first I will see the data. I will observe that, okay, this person has spent earlier on the TV 2,30,100 and 37,800 on radio and 69,200 on the newspaper, and he has got 22,100. And 44,500, 39,300, 45,100 and 10,400. Now 18,500. Now for exact 20,000, there is no answer. Now for that, I want to predict. For example, if I'm having with assume that I'm investing 1,50,000 on TV, 1,50,000 on TV, and 45,000 on radio, and on newspaper some 90,000. Assume this is the amount I'm investing. For this, what is the expected sales? You have to predict the answer. You can't predict on your fluke, na? You can't say approximately, sir. Approximately this will be there. Not approximately. I'm asking with respect to what that approximately, what is the percentage of that approximately only. Okay, approximately you are saying, sir, it is going to be 25,000, sir. 25 units, 25,000 units will be sold. Okay. For that, what is the probability? 25,000 you are saying number. What is the probability for that number? There should be some number probability, right? So that we are going to see here. Now write in your notes that if a person wants to invest 1,50,000 on TV, 45,000 on radio, and 90,000 on newspaper, and what is the expected sales? This is the question. This is my business problem. For that, I have given you the data set. Now, observing the data set, you have to predict the answer. Whether you apply the linear regression, whether you will apply non-linear regression, whether you will apply another regression, that is your choice. Choice is yours. But I want the answer with maximum accuracy. That is my requirement. Which algorithm? You have to apply this algorithm only. I'm not saying any condition like that. I want the answer with maximum accuracy. That is my requirement. So the client will ask like this. If I invest this much of amount, or for example, not only for this number, if I invest 1 lakh on TV, 10,000 on radio, and 2,000 only on the newspaper. Now, if I invest 20,000 on newspaper, I will keep remaining 2 or same. Now, if I improve this one to 40,000, now, just identify the relation and submit the equation. He will only substitute different values and he will only see the answers. He will substitute the different values of TVs, different values of radio, and different values of newspaper, and he will only observe that value. What is the answer according to that? Now, here what I'm going to do is, for first I'm going to check in the records. Total how many records are there? Means 200 records are there with 4 columns, out of which one of the output variable, 3 input variables. And is there any missing values? Miss, there is no missing values in my data set, right? Sir, why you selected clean data, sir? You can show us some unclean data set where we have to do that. That we'll see in the next project. Everything, if you include in one project, it is going to be so much of complicated. In one project, we'll see one thing, and you combine everything. In one project, we'll see everything later. That is called as capstone project. Last, right? Now, first I'm going to do the describe function and understanding the data, and I'm applying the pair plot. Now, after applying the pair plot, now automatically it will give the different plots, like this is x1 variable, x2 variable, x3 variable, x4 variable. Now, here x1, x2, x3, y, x1, x2, x3, and y. Now, x1 versus x1, histogram of x1. This one is scatter plot by selecting the x1 on y-axis, x2 on the x-axis. This one is selecting x1 on the y-axis, x3 on the x-axis. This one is selecting x1 on y-axis, selecting y variable on the x-axis. Now, what is the scatter plot I have to observe is, my requirement is output variable should be on the y-axis. Input variable should be on the x-axis. This is my requirement. So, which column I have to observe? Means which row I have to observe? The 4th row I have to observe. In the 4th row, I am having with respect to the output of sales. So, now this is the sales versus TV, sales versus TV. Sales versus radio, sales versus newspaper, right? From this scatter plot, I'm going to observe this one. Okay, this is having linearity. What are the 3 things you have to observe from the scatter plot? 1, whether it is a linear or not. 2, direction. 3, how much the data points are close to each other. When, here, there is a linear. It is also linear, but this is not that much of linear. But still, assume that it is linear. Now, whereas the data points are very close here, here the data points are somewhat far away, whereas this one still more far away. When compared to this one, as x values increases, y also having with, if x value, this is the x value, this is the y value. Now for this x value, y value also has increased. From here to here, you have increased the x value, means y value was also increased from here to here. Now if you observe a data point, this data point, x value is this one. For this data point, x value is this one. Okay. Now, from here to here, as x value increases, y also increasing. It is a increasing direction. Direction is positive direction. Now, here also the x values are increasing. But here, if you observe, for certain x value, the x value, y values here also is there. The same for x value, y value, one more is there. Whereas it is having less correlation comparatively. That I am observing this one. But exact values, I don't know. Exact value of correlation, I don't know. I know only thing is the data points are comparatively this, in this case, very close to each other. In this case, somewhat very far away to each other. In this, too far away. That only I can understand from the scatter plot. Now, exact values, you can get the correlation coefficient by applying the correlation matrix. Whatever the correlation matrix is there, Now you can observe the sales versus TV 0.78, sales versus radio 0.57, sales versus newspaper 0.22 only. Same thing, the data points are very close to each other, so correlation is high. If the data points are very not that much of close to each other, the correlation is less automatically. Okay. Now, the relation between X and Y, whatever the relation between X and Y, it should be very high. If the relation between X and Y it is very high means it is called as a good correlation. If the relation between X1 and X2 is high means then it is called as collinearity problem. If the relation between X1 and X2, the relation between, write in your notes clearly, this one. Relation between independent variable, the relation between independent variable to dependent variable, the relation between independent variable and dependent variable should be high. Should be high. If it is high, then we'll get a good model. Indicates it is a good. If it is high means good. They are having good correlation, so that prediction also will be done easily. And we can predict. If there is no correlation between them, how you are going to predict? For example, there is no correlation between the last bench student versus first bench student. There is no correlation. Then when they will discuss to each other, whether they both knows their names also, we don't know. But you are sitting side by side, your friend name you know, because you are having a good correlation. If you are sitting very far away to each other, then there is no correlation. If there is no correlation, then how I can predict the pattern between you both? If the pattern, if I am observing that things means I can predict that, okay, these both are coming every day together, they are coming and together they are going, means these both are very close friends. I can identify that one. Based on that, I can identify some pattern is there. If none of them is coming, for example, one person is coming separate time and one person is coming very lately, how we can identify? Right? We can't say this one. So if there is a good correlation, the prediction will be easy. Then identifying the pattern will be easy. Pattern identification will be easy. If there is no correlation, means pattern identification will not be good. And automatically prediction also will not be good. If there is no correlation. At the same time, if the relation between independent variable to independent variable to other independent variable, if the relation between independent variable to other independent variable is high, then it is called as collinearity problem. It is called as collinearity problem. When there is a collinearity problem, automatically the accuracy will be very low. The accuracy will be low. Now, for this understanding, I am explaining with a simple example. Assume the independent variables are nothing but students. Dependent variable is trainer. If the relation between independent variable, that is student between the trainer, if the relation is high and they're free to ask, they are able to ask the questions, they are able to free to ask the questions to the trainer. Sir, this is the doubt, sir. I'm having the question. If they are asking me directly, then there is a high probability they'll learn the subject more, and there is a high probability that they'll not have any kind of fear in the interview room. There is a high probability that they'll not have any kind of fear to discuss with their team manager level people in the future. Their seniors will be there, right? In the companies, some seniors will be there in the project. To discuss with the senior, will have a fear that, whether if you discuss or not, if I ask that question, means that senior will think in a wrong way. That students will think in that way. Now, for example, if the relation between the trainer and the student is very high, means it is a very good. So that he will discuss whatever he is having, his opinion he will share. For example, he is asking a wrong question, I will only correct them. Okay, you should not ask like this type of questions in the company. You correct yourself, I will say something. Now, if for example, between the students, one student and another student. If one of the student has got one doubt and he is asking another student, the relation is very high between the independent variables. Relation is high means between the students very high. Means assume that student 1 and student 2 both are friends and their relation is very high. They're close friends and the relation is high. And one of the student has got one doubt. Instead of asking the trainer, he will ask the student 2 and the doubt will be cleared. Okay. Now, after going to the company, to whom they are going to ask? The same friend will be continuing in the company also. In the company, what you are going to do? That is the reason accuracy will drop. Is that clear? Example wise. Similarly, here also the same problem. The model also, if there are two variables are there and they are having very high correlation, one will dominate the others. And the p-value will not be significant. How it is going to do that one also, I'll show you. Okay, there is one more data set where there is a collinearity problem. In my case, it is not having any collinearity problem, but in the one more data set, I will show you that one. Okay, so here, how to observe that one means, first you have to see that TV versus radio. What is the collinearity? Sorry, what is the correlation? So the correlation is 0.05. It is a less. The relation between TV versus newspaper, it is less. The relation between radio versus TV, both are same, na? Relation between TV radio and radio TV also both will be the same. This part, whatever the value is there, the same thing will be there. Just you have to observe without the output variable. Don't consider the output variable. No need to consider the output variable. Between the independent variables, whatever the independent variables are there, between them, just you have to observe the upper triangle matrix. No need to come to the lower also. Just observe the upper triangle matrix, that to independent variables only. No need of output variable also. Okay. Now these three values, if you check the relation between these three, means relation between TV, radio, TV, newspaper and radio. If you observe these three relations, now if the values are less than 0.5, they are said to be a low correlation. If the values are between 0.5 to 0.8, moderate correlation. If the values are greater than 0.5, strong correlation. Less than 0.8, less than 0.5, less than or equal to 0.5, it is called as weak. Less than 0.8, it is called as moderate. Greater than 0.8, with respect to good. Or high, strong. We used to call as strong correlation. If there is a weak correlation between them, means no problem. They are having the weak correlation between the independent variables also, no problem. Okay, continue. For example, in this class, your friends, you are taking the phone numbers, you are exchanging the phone numbers and everything. No problem, absolutely no problem. If any day, if there is no class, miss, to intimate to each other or to that one is okay. But if you are having a strong correlation and you are discussing the questions, assignment questions, or you are practicing together, or you are taking the exam together, that is problem. There should not be a strong correlation. There should be a weak correlation. Okay. Not with respect to friendship. In terms of subject, I'm saying. Your friendship is entirely different. Right? I'm saying about only from the subject perspective. In the subject perspective, don't discuss with your friends. Learn on your own. Because on tomorrow, once you join the company, you have to do on your own. Remember, your friend is not going to be with you in the company. Your friend will work in another company. And on the spot, you have to rectify the mistakes. I will go to home, sir. After going to home, after 10 o'clock, I will send the answer, sir. You can't say right in the company. I'll ask my friend and after that I will send. One day they'll observe, 2 days they'll observe. Then they'll understand you are doing something of false things. That is called as proxy. Someone is helping you and you are doing it. Whether he is helping free of cost or whether he is taking money and helping her, that is secondary. But someone is helping for you. That is the reason you are not performing in the company. After going to home, you are performing. Means some unhidden person is there back end. Right? So they'll identify. In the companies, they'll identify easily. So remember that in the company, no one will be there. So you have to work on your own. Right? So here I require the relation between the independent variables should be very low. Correlation. The correlation between the independent variables should be very low. If you are having a correlation, if the correlation between any two independent variables is strong, then it is called as collinearity problem. This is the interview question. Right? Now here, data cleaning. I no need to clean the data. That is no missing values are there. Data wrangling. I no need to do any encoding. For this data set, there is no encoding also. Just again, I'm applying the baseline model. Directly, I'm selecting the data. I'm applying the model. Blindly, I'm applying the model. Now, X is equal to df dot drop of sales. Sales column you have dropped means what are the remaining three columns? TV, radio, newspaper that you are considering in the X. And sales table, whatever the sales column is there, that is in the Y. If you want, you can check yourself. X. What is the X? TV, radio, newspaper. Three variables are there. What is Y? The output variable. Where X is in the data frame. X is a data frame. Y is a series. Y should be in the series. Y should not be the data frame. Because this model, whatever this function is there, inside this function, we have to fit the X and Y. X should be the data frame. Always X should be the data frame model. If the X is in series means you have to convert to data frame. Otherwise, it will show the reshape error, convert to 1, -1. Means asking to convert the series to data frame. For example, you have selected only one. DF of TV you have selected. Now, what are the TV values you are going to see? That's individual column. The output is series. If you ask the type of this one, it is a series. Now, that type of, if you ask DF of TV in this way, the same output will be displayed, but output is, type is data frame. The X should be always in the data frame. The X can't be in the series. The X variable should be always in the data frame, which when you are fitting the model. If you don't fit the model, okay, choice is yours. If you fit the model means the machine learning algorithms, the X values should be always in the data frame. Right? Now, from the sklearn dot model selection, import the train test split, and I'm going to take the test size of 0.3 and random state of 42. Now, here from sklearn dot linear model, import the linear regression, and model is equal to linear regression and model dot fit on X train Y train. Same code, right? Yesterday also I have written the same code, copy paste. Yesterday also I have written the same code, copy paste. Yesterday also I have written the same code, copy paste. What I have changed? Coding is nothing. Nothing is there in the code. Same to same, copy paste only I have done. Right? And intercept. How many intercepts you are going to get? One intercept. How many quotient values you are going to get? 3 quotient values. Now, this quotient belongs to which one? TV, radio, or newspaper. That you have to see in this. Whatever the model you have used for the X train, just click on the X train. In the X train, whatever the first one is there, that one is the first variable. Okay. So beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 is the equation y hat. And this whatever the value you have got is 2708.94 plus 0.044 into TV plus 0.199 into radio plus 0.0006, sorry, not 006 into newspaper. This is the equation. The relation between sales versus this one. Now, whatever the question I asked you earlier, that is 1,50,000, comma 45,000, comma 90,000. Just substitute TV 1,50,000. Substitute for radio, substitute for newspaper that value and predict the sales. But before doing that one, whether this model is a good model or bad model, you have to check. If it is a bad model, you should not apply the prediction. If it is good model only, for that only you have to predict the answer. If it is a bad model, relation itself, it is a wrong relation, then what is the use? I can write myself also, sales is equal to 10 lakhs plus 2 into TV, 9 into radio, 24 into newspaper. I can also write, na? Directly if I write like this. But this model is a good model or bad model? How to check? So you have to check the evaluation. You have to do evaluation. So in order to evaluate, first we have to do the prediction. So the same thing, yesterday whatever I have done, model dot predict on X train, model dot predict on the X test. Yesterday also we have done the same, right? In the simple linear regression also we have done the same. Before to that, before to class, whatever the in the class we have done the mathematics, then also we have done the same, and the same steps you have written. Select the X and Y. After that, train test split. After that, apply the model. After that, predict on X train and predict on X test separately. You have written right notes. The same thing in the last class. See, same to same, copy paste only I have done. Same to same code is copied. After that, intercept is copied. Same again with respect to quotient is copied. And after that, predictions. What are the predictions are there? Here, the predictions, the names of, so I have copied as this. Right? Now, next evaluation. Yesterday class, I have shown you mean absolute error, and I told you that you should never apply the mean absolute error. But there is an option. Mean absolute error also, one of the option is there, but you should not apply in the data science because it is having a differentiation problem. Mean square error also you should not apply because it is having the units will be squared. What is the thing you have to apply is only the RMSE. So copy this code and I have pasted here. Directly I am calculating only train RMSE and test RMSE. Print the train RMSE, print the test RMSE. This is the train and this is the test RMSE. Next, after that, what I have done? R square. Test is either using this one or this one. Anything of your choice. I have selected this one. My choice is this one. So I have opened this one and I have selected this one. Train R square I have got 90. Test R square 86. Now, if I apply the checklist, is the model is having overfitting or underfitting? No, it is not having either overfitting or underfitting because the difference is just 4%. So that is not a problem. So it is not having either overfitting or underfitting. It is a good model. Second one, is the test accuracy is equal to cross validation score? The same thing, not yesterday also the same checklist, right? First we have checked whether it is underfitted or overfitted. After that, test accuracy is equal to cross validation score. Same to same. 88 and here it is 86 test accuracy, almost same. So train accuracy, I will write that train accuracy, it is 90%, test accuracy of 86%, CV of 88%. Okay. Now, after that, what we have done in the simple linear regression, we have checked for the assumptions. Accuracy is fine. Accuracy is very good. Now we are checking for the assumptions. Out of which first assumption? What is the first assumption? Linearity of errors. How to check that one? First, you have to calculate the residuals. Residuals are nothing but errors. Errors and residuals both are same. Technical word is called as residual. What is meant by residual means nothing but error. Original value minus predicted value. Right? So the same thing. Copy paste I have done. Again, I have checked the same scatter plot. Now here, if I observe the scatter plot, this part is extra. So this part is scatter. This is okay. Linearity it is satisfying, but this part is not satisfying the linearity. Okay, sir, that much of clarity is not there for me. Okay, let us assume this is also linear only. Assume. Okay, let us go with the next one. Normality. Now, normality of errors. From this, we can clearly say it is a left skewed. Can you assume it is a normal distribution? Huh? It is clarity is there, right? So it is a left skewed. Left skewed means assumption has failed. One of the assumption failed also, overall it is failed on. Sir, now you have got train accuracy 86%, test accuracy 88 and cross validation 88. Nah? Though you have got here 100 also, if assumption failed also, worst model one. With assumption satisfied only, that is called as good model. If one of the assumption failed also, linear regression is not a good model. Then what we have to do? If assumptions fails, what we have to do? That only today's class. What we have to do if the linear assumptions fails in the linear regression, then what is the next step? Okay. So here, out of line assumptions, first we have checked for L. L failed. Next, N. N also failed. E. Let us see for E. E also will be failed. Okay. Of course, sometimes it is not mandatory that all of them may be failed. At least one failed also fail only. If one of them failed also fail only. Right. And you are going to check the variable significance. Yesterday also I have done first linearity, followed by normality, followed by equal variance, followed by variable significance. Whatever the code is there, copy paste only I have done. So here I no need to explain once again the code, right? Now directly I will execute. Again, if you think that sir is going fast miss, then you have missed the yesterday's class. If you have missed the yesterday's class, today's class for you, everything will be the some kind of Mookie movie. Because yesterday we have discussed what is the fitting and what is meant by this one. Everything we have discussed in the last class. Without learning the last class, if you sit in today's class, miss, you will not understand. Is there any person in this class who has missed the last class and sitting in this? Ask them. Okay. Try. You want, if you want, you can ask them. But I will not explain. If I start explaining, every day one person will be absent, right? Tomorrow one person will be absent. Tomorrow I have to explain, revise. No, I can't revise like that. You are saying from your perspective, I am saying from overall perspective. Every day one student will be absent. Every day revision is not possible. You have to learn. You have missed the class, miss, you have to learn on your own. Okay. You have done a mistake means you have to take the punishment, obviously. Right. Now, first we have done with respect to this one model. Whatever the model is there, if you see here, R square, F statistic and probability. This p-value is less than 0.05. P high, P low, null go. Null go means reject the null hypothesis. What is null hypothesis? Average line is the best fit line. You reject that one. Regression line is the best fit. When regression line is best fit, automatically R square will be in the positive. So you can see the positive value of R square. Now, if you go with the individual values. So now individual values, what for this particular beta 1? Beta 1 means whether the beta 1 has to be selected or not. If the beta 1 is equal to 0, null hypothesis says that beta 1 is equal to 0. An alternate hypothesis says that beta 1 is not equal to 0. And you are applying the one sample t-test, and based on the t-test, you are getting the p-value. Based on the p-value, you are going to accept or reject. B-value is less than 0.05, reject the null hypothesis. Means beta 1 is not equal to 0 means in your equation, beta 1 also has to be considered. You have to consider the beta 1. Now, beta 2. Beta 2 has to be considered in your equation or not? Yes, it has to be considered because null hypothesis says that beta 2 is equal to 0. Alternate hypothesis says that beta 2 is not equal to 0. For this, it is applying separately one sample t-test, and this is the test statistic and this is the p-value. And based on the p-value, you are once again rejecting this one and you are accepting this one. So beta 2 also you are correcting. Now, H0 is equal to beta 3 is equal to 0. H1 says that beta 3 is not equal to 0. Now, here the p-value is greater than alpha. P is p high, null high, means beta 3 is equal to 0. Beta 3 is equal to 0 means if you substitute 0 in this position, it is not a valid one. Just ignore. If it is 0 means what is the meaning? That variable you are not considering. If you multiply with 10,000 also same. If you multiply with 1 lakh also same. Though you are investing 1 lakh on newspaper also, it is not going to affect on the model. If you imply 10,000 also, it will not impact in the model. Because this variable we have to don't consider this variable. Hypothesis test was failed on this variable. So why hypothesis test was failed? Because if you observe the same thing in the AV plot, just if you see in the AV plot. So here I'm going to collect this one, that is from statsmodel.api. I'm importing as SM. Inside that there is an option called as plot part regression grid is the function name. What is meant by part means partial regression. Now it is applying the partial regression. Do you remember that equation, simple linear regression? I have told you beta naught plus beta 1 x, simple linear regression. And from this, how to calculate the beta naught and beta 1? How to calculate? That is sigma of x minus x bar into y minus y bar. That is formula. Okay. From where you got that one? From where you got? SSC has to be minimum. In order to be this one minimum, first that is XSC is nothing but y minus y hat whole square should be minimum. That is nothing but y minus beta naught plus beta 1 x. Whatever the equation is that we are substituting here. And this value should be minimum. That is y minus beta naught minus beta 1 x. This should be minimum. In order to be minimum, that you are going to do the derivation of this one with respect to x. And you are substituting that x is equal to 0. And you are going to get the minimum point. Now, what are the differentiation you are doing this one? The differentiation of this single equation you have done and you have got the equation. Now, here we are having with respect to 3, that is y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Now, I am applying the linear regression concept. Linear regression means OLS. What is meant by OLS? Sum of the squares of error should be minimum, which is nothing but sigma of y minus y hat whole square should be minimum. This value should be minimum. Y hat is this one. Now, what is sigma of this one? Y minus beta naught minus beta 1 x1 minus beta 2 x2 minus beta 3 x3. For this whole square, this should be minimum value. For doing this minimum value, we have to do the d by dx. For identifying the minimum value, d by dx, whatever the equation it is, we have to apply the d by dx. Now, if you are applying the d by dx on this equation, now what happens is here For individual values, individual x1, you have to apply separately x1. For individual of x2, you have to apply x2. With x3, you have to apply with d by dx of x3. You can't take overall x. There is no overall x. x1, x2, x3 separate are there. Whereas simple linear regression, it is having only one x. Directly only one x is there. But here you are having different x. So d by dx1 you have to do, d by dx2 you have to do, d by dx3 you have to do separately. Now d by dx1 you have to do means you can't do d by dx1 separately. That is called as dou by dou x1. Dou means nothing but partial differentiation. Now whenever you are applying partial differentiation, other remaining two parameters will be constant. It is not going to consider the remaining two. It will apply only on this. When you are going with dou by dou x2, automatically it will apply the second one and remaining two parameters will be constant. When you are applying dou by dou x3, the remaining parameter will be constant. That is x3 it will apply and x2, x1 and x2 will be constant. Now the same thing will be applied here. You don't need to do any max. Automatically function is there and just you have to see this plot. This is going to be applied with respect to this one. So now can you see here? This is the y versus x1. Whatever the x1 is there, that is TV. TV versus x of 0. X of 0 means in x train, what is in the 0 position? TV. X of 0 means that is the meaning. So TV versus y variable. TV versus y variable. Can you see the regression line? Regression line is the best fit line. In the TV versus, next one is radio. Radio versus your y variable. Again, there is a regression line. But whereas with respect to newspaper versus says, there is a horizontal line. Horizontal line indicates that beta value is equal to 0. Slope is 0. Slope is 0 means coefficient is 0. You can observe this one. That is the reason it is failed. So here the same logic will be applied. You don't need to do this one also. You don't need to check also. Because just I'm explaining the backend how it is working. Backend of hypothesis test I'm explaining. So it is going to check with respect to that one. And here we can clearly see this is a horizontal line. Horizontal line indicates it is a slope coefficient is 0. So coefficient is 0 means don't consider that particular variable. Now in this case, what we have to do, whenever the p is high, that particular variable we have to delete. Whichever the variable is not satisfying this condition, that particular variable you have to delete. But before deleting the variable, so here if you observe TV, radio, newspaper, I am having only 3 columns, out of which one of the column if I drop, 33% of the data is getting dropped. Out of 100% of the input variables, 33% you are dropping off. So much of amount is getting dropped. So instead of dropping off that much of amount of data, can we try with less amount of data? Is there any possibility? Means what is the meaning of that? TV. How many values of TV are there? How many records are there total? 200. 200 values. How many radios are there? 200. How many newspaper are there? 200. If I drop one of them, 200 values will be dropped. 200 values of newspaper will be dropped. 200 values I am not going to consider. Instead of that, if I remove one of the row, how many values will be dropped? 3 values only. Now 200 dividing by 600, 33% of the data will be dropped. Whereas three values, if you remove any one row, only 3 values will be dropped. 3 divided by 600, which is just 0.0. How much percent? 5 something. Okay, approximately I'm writing. It is less than 1% only. 0.5%. 1% means 6. 1% means 6 records. 0.5% means 3 records. 0%. If you are asking in percentage means you will get with 00. Okay. So now whatever the percentage is there, that is very less percent I am calculating. Just if you multiply with 100 into 100 you have to do. Then you will get 0.5 only, right? Otherwise this one also 0.33 only. 333 one means into 100 you have to do, right? So similarly 0.005 into 100, 0.5. So now whatever the percentage, 0.5 percentage you are dropping. So which is a negligible. 99.5% of the data you are considering, just 0.5% of the data you are dropping, which is considerable. If you are dropping 33% of the data means, which is not considerable. So now you have to drop the 1 record or 2 records like this. Now, sir, which record you are going to drop? which are having with respect to influential records, which are influencing, which is influencing that one that I'm going to draw. So now what is the difference between this influential record, influential plot, influence value versus outlier? What is the meaning of this? What is the difference? For example, in this class, we are having the students, data science students are there. Inside the data science students, along with that, one of the student is sitting is full stack student, Java student, assume full stack Java student is sitting. He is called as an outlier that everyone knows, which is different. Now, in the same data science only, every student is data science student only, but one of the student is going to influence the others. Influence means, for example, he is going to ask in between multiple questions. Sir, he will rise. The moment I complete one statement, he'll ask the question. Immediately, he will ask the question. He will not understand, others also will not understand. He is going to influence. One student who will sit in the first bench, for example, he is sleeping, assume. Some other students, they'll observe, they'll also get slowly into the sleep. He is influencing. Example, right? So these are called as influential. They'll be inside the part only, but they'll influence the output. They'll be part of the data set, but they influence the output. They are called as influential records. These are also dangerous only, but not when compared to outliers. Now here, this same thing I'm going to get by using the influential plot. You just apply the influence plot. Now in this influence plot, you can check which is having the more influence. How to check that one means which circle is large, that is having more influence. The larger the circle size, the more the influence it is having. Now, out of all these things, this particular circle is very high, which is 130th record. Record number of 130th. Row index number of 130. It is showing the index number. 130 row index number, it is having the problem. So I am identifying what is there in the 130. Why it is showing like that. Now, TV is having 700 only. Radio is having more, but still they have got with respect to good amount of sales. This much of amount they have invested. 39,600 they have invested, but they have got with respect to 1600 only. So 130th record. 130th record means it will be in the 132 position. So now here if you observe this one, 700, 39,600 and 8,700. What is the cumulative of this one? Total amount? Approximately, not exactly, approximately 39,000 plus 8,000 is 47,000, 47,000 and 48,000, approximately 48,000. Let us make it round figure to 48. For 48,000 of dollars, they are having 1600 units. Now, for example, if you go with this one, let us take this one. 8,400 plus 27,200 plus 2,100. Approximately what is the amount? It is 37,000. 37,000 only you are getting directly 5,700. Whereas if you observe this one, here 59, which is 60,000 plus 1,03,000 and 1,15,000. For 1,15,000, you are getting 9,700. So now if you, here more amount was invested, but very, very less amount of sales. Maybe some error. There might be entering instead of 21,000, 2,100 only they have entered. Maybe. May not be. We don't know. But this is something different. Sorry, not this one. This is something different, which is having very less amount of 1600, which is having very something different. In this, either some value they have missed, either 7,000 or something they have missed, and they are having very less amount of sales only, right? Or they have, with respect to what are the sales, number of products, number of units, what are the number of units are there? That is very less. So now this, if you consider this one and if you consider this one and this one, guys, just forget about nothing. Data is there. About data is not there. Assume there is no data. You are having only these three. Just observe only these three. Okay. This is the, just you make the total. Total is 1,15,000 of this first record. I'm writing in this one. This is 131,500 approximately. And 9,700 is the answer. For 48,000, 1,600 is the answer. For 2,65,000 plus 2 lakhs, approximately 3,05,000. Approximately 3,05,000 if you consider, it is 12,700. Now, if you observe this one, where we are having with respect to 8,000, approximately how much amount? 35, 37,000. For 37,000, you are having 5,700. From observing these four values, can you tell me for 1,50,000 what would be the price? How many units will be there? Just by observing. From your perspective, just by observing. Around 8,000 or 10,000 or something like that, right? 8 to 10,000 or something around like that. Now, based on that, we are estimating 10,000 or 11,000 or something value. Now, for 48,000, for 1,50,000, it is 10,000 means for 48,000, how much value should be there? 1/3, right? 1/3 of that one means 3,300 should be there. But here it is only 1,600. That might be on that day, any band was there. And they have not given that much of sales on that particular day. Maybe. We don't know. The reason we don't know. But using this value, the entire prediction is getting wrong. If I focus on this value, the entire prediction of this one I'm estimating is getting wrong. Without this value, if I do the estimation, I'm getting somewhat better. Relation I'm able to identify. But this in one record is confusing me. It is deviating me. So this is called as influential record. Okay. Those records are called as influential records. Now what we are going to do is we are going to drop those influential records. So now how many records you can drop up to miss? Out of 200 records with 5%. 5% of that miss 10 records you can drop. Up to 10 records, if you drop also, there is no problem. If more than 10 records, if you want to drop miss, you have to statistically prove why you are dropping that one. Up to 10 records, choice is yours. You play whatever the game you want. If more than that you want to drop miss, you have to statistically prove. Miss, sir, this is having the influence, or this is having the outliers, or this is having this problem. You have to statistically prove. Without statistically proving, you can't drop as per your choice. No, sir, I'm not interested in that record. I don't want to consider that one. That is not your choice. You can't select like that. Up to 5%. Choice is yours. You can do whatever you want. No problem. Right? So here, whatever the numbers it is displaying, 135, 75, 165, I'm dropping those records. Or if you want, you can drop only one record also. If you want one record, you drop one record. If you want multiple records, you drop multiple records. I have dropped the multiple records. Again, I'm applying. Now, if you see this one, still the p-value is high only. This is one way of dropping. If you drop miss, it might reduce. The p-value has reduced to less than 0.05 miss. We'll continue with the newspaper. But still it is not showing that one. Still the newspaper is not significant. Still it is saying that once again it is saying that remove the newspaper. After removing the 4 records also, still it is saying that remove the newspaper column. Don't consider the newspaper column. Now what I'm going to do is I'm going to check the how much one of the variable is influencing the other variable. That is how much TV is influencing the radio and newspaper. How much radio is influencing the TV and newspaper. How much newspaper is influencing the TV and radio. Means here I am considering this one as the output variable and these two I am considering as the input variables. This is Y variable and this is X1, X2. This is Y variable X1, X2. This is Y variable X1, X2. And I will apply the multiple linear regression for this, multiple linear regression for this, multiple linear regression for this. And I will calculate the R square, R square, R square. And if the R square is very high, this is having a good correlation, good coefficient of determination with respect to this one. If the R square is very low, no matter, not a problem. So now the same thing I'm going to do in a single line. No need to do multiple lines. Just smf.ols, take the TV over radio and newspaper and data is equal to df and fit the data. Now, once you fit the data, you will get the R square value. R square is very, very low means what is the meaning? There is not having any relation. There is no relation. If the R square is very high, accuracy is very high, good correlation. R square is very low means there is no correlation. There is no relation. So TV is not influencing the others. Similarly, I'll check with respect to the radio. Copy the radio. Now I am going to consider the radio. Whatever the radio is there, I'll consider in this position radio. In this position, I will consider the TV and newspaper and I will check the same thing R square. Similarly, I will check with respect to the newspaper, I will take as the output variable and remaining two I will take as the input variable. Again, I will check the R square. And whatever the R squares I am getting, this R squares whatever the R square you have got, R square 1 divided by 1 minus R square is called as VIF, which is variance inflation factor. VIF. So based on the VIF also, that is variance inflation factor. Based on the VIF also, we can conclude. So if the R square is low, if the R square is just 0.05, what happens? 1 minus 0.05. What is the value? 1 divided by 1 minus 0.05. Sorry, not 0.05, 0.005. 1 minus 0.005. What is the out? This one, which is nothing but 0.995. 1 divided by 0.995, which is nothing but 1.01. Approximately. I'm saying approximately, not exactly. Right? So now whatever the value you have got, this is the VIF of, by considering the R square of TV. TV as the output variable you are considering and you have got. Similarly, consider the VIF of with respect to radio. Means calculate 1 divided by 1 minus R square of radio and check the VIF value. Similarly, calculate the VIF value for the newspaper also. That is 1 by 1 minus R square of newspaper as the output variable. And calculate the 3 VIF values. What are the VIFs you are getting? You calculate the 3 VIF values. See, I'm calculating the same way. So first I'm going to take the TV as the output variable and I'm fitting the data and I'm calculating the R square. What are the R square I have got? I'm substituting in this and I'm calculating the VIF. And I'm taking the radio. Radio I'm substituting here and whatever the R square I have got, that I'm substituting and I'm getting the VIF of radio. I'm taking the newspaper as the output variable and I'm calculating the R square and whatever the R square I have got, VIF of newspaper. Like this I have got 3 of them and I'm going to create the data frame. VIF of TV, VIF of radio and VIF of newspaper. Each of them I have got. Now whatever the VIF you have got, now if the VIF value is greater than 4, then only it is called as that variable is affecting the other variables. Otherwise, no problem. Sir, why 4 only? Just VIF of, let us assume VIF is equal to 1 minus 1 by R square. This is 4. 4 is equal to 1 divided by 1 minus R square. That is nothing but 1 minus R square is equal to 1 divided by 4, which is nothing but 1 minus R square is equal to 0.25, which is nothing but R square is equal to 0.75. Whenever the R square value is greater than 75%, that is influencing. That is having the problem. If R square is less than 75, no problem. There is no problem with that. Now here all the R squares are very less. So from VIF also we can't conclude anything. From if the VIF is greater than 4, directly we can say that newspaper is the worst one. We have to delete. There is no other option for you. Now you are going to drop the 33% of the data. You are statistically proving that one. Why you are dropping? Because statistically proved that VIF is very high. VIF very high means indirectly R square is very high. Since R square is very high, it is having the effect on the other variables. So in that case only it is having the problem. So in my case, collinearity problem is not there. Na? So that is the reason VIF you are not able to observe. If there is a collinearity problem, VIF value will be more than 4. If one of the variables, I will show you one more example. Okay. If you are interested, you write the notes. Take the data set. Choice is yours. You can select as per your choice. Of course. Okay. Don't write now itself. First, let us complete this one. Later, I will give that one as an assignment. Right. Now here, whatever the VIFs are there, from the VIFs also, I am not able to identify. If there is a collinearity problem is there, assume in my data set, there is a collinearity. In this collinearity, 2 variables will not be significant. 2 p-values will not be significant. And that is x2 and x3. 2 values will not be significant. Now, in this 2, I have to drop 1. Which I have to drop? Which variable I have to drop? Means which variable is having the highest VIF, that variable you have to drop. Whenever you have to drop means that variable should have the highest VIF. That variable only you have to drop, which is having the highest VIF. I told you, right? The relation between y versus x should be very strong. But between x versus x2, it should not be strong. It should not be, here it should be very weak. R square should be very low. The lower the R square, the better the model. In this case, the higher the R square, the better the model. Is that clear? So finally, from all these things, I'm going to confirm that I'm going to drop the newspaper. Directly, I'm going to just use the says TV and radio, and I'm going to confirm the date. Now, here, whatever the ask pair and now the p values, everything are significant. Now, I'm going to fix only with the TV and radio. So now what I'm going to do is, after finalizing everything, now here, now my x value, x is equal to, what are the x is equal to df of those two columns. What are the two columns? One is TV, comma, second one is radio. These two only are considering as the x variables. And y variable you are considering as df of sales as it is. Now from here again you are going to start from this one. Whatever you have written now, again this is the position you have got now. Now we are in this position. Now again you have to do the train test split. Again you have to do the model. Again you have to do everything. So again you have to do means nothing but copy paste you have to do. I am doing the same. Copy. Okay. Now the latest x and y is only this one. Okay. Paste. And after that, now it is going to consider this x. Now what is the x value? Only these two columns is the x. Okay. And next, I'm going to copy the model. Again, go back and copy. Copy only. Copy. You can create in the new cell or you can copy in the same cell. I'm not having that much of interest to create new cell. I'm copying in the same cell. Choice is yours. And next, copy. Which one? This train. Prediction of train. Testing on train. So instead of copying, I'm executing here itself. Already the x values was selected, right? So I will change the x value here only. I will change only the x and y. Directly I will do this one only. This will be easy for me. Instead of copying these many things, I will copy directly this x and y on the top. But you should not do like that. Okay, you have to copy that one in the down and you have to continue. Right? So I'm selecting only these two and I'm applying this train test split. After train test split, I'm taking now the X train is only two columns are there, TV and radio. I'm fitting the data. Now, if I fit the data, I will get the intercept and I will get the quotients, only two quotients. And I'm going to apply the predictions and I will check with respect to train RMSE, test RMSE, train square, test R square. And I will check with respect to cross validation score. Again, I have got 90, 86, 88, same thing. Now, I'm going to check the assumptions. Now, what are the assumptions are there? I will check with the assumptions. Now, these assumptions, when compared to earlier, these assumptions I am meeting or not. I'm just checking with respect to the assumptions. Now, if the assumptions are satisfied, well and good. If the assumptions are not satisfied, again, you have to check what is the problem. And you have to rectify that according to that. Right? Now, finally, which model you have selected? You have selected only with two columns. That is, now you are predicting the output with respect to two columns. Now, sir, in the given question, they have asked with 1,50,000, 45,000. TV, 1,50,000 if I invest, 45,000 if I invest on radio. If I invest in newspaper, 90,000, what is the expected value? They asked this question. Now, what I'm going to do is, based on whatever the output I have got, here after removing that particular variable, whichever the variable is not significant, that particular variable I have dropped. After dropping that particular variable, now what is the equation is? Y hat is equal to, that is 2837 plus 0.044 into TV plus 0.202 into radio. And I'm going to predict the sales. So 90,000 they have invested on the newspaper. What is the expected value they're asking now? Before to that, I will say to them in the meeting that, sir, newspaper is not having any importance. No need to imply in the newspaper. Instead of having in the newspaper 90,000, invest on the, instead of this 90,000, invest on TV or radio. Which one you have to invest more, miss? Which is having the higher the quotient value, that one is the best one. Okay. The quotient of this, for example, let us see this one. Now, X is equal to 1, 2, 3, 4, 5. Y is equal to X plus 5. Y is equal to 2X plus 5. These are the two equations are there. One is X plus 5, where the quotient is 1 only. In the second case, the quotient is 2. Now, for this one, tell me what is the output? 6, 7, 8, 9, 10. Now for this, using the second equation, first one is 7, 9, 11, 13. What is the difference between these two? Difference between this one and this. The change in x, what is the difference in change in x? 1. For change in x of 1, how much y value is getting changed? That is quotient value, it will change. The change in x is equal to 1. How much it is changed here? That is quotient value. The change in the y is with respect to quotient value. So now to take the third equation. Y is equal to 3x plus 5. Intercept will not have any impact on the intercept. Now third equation. 8, 11, 14, 17, 20. Right? Now change in x is 1 only. Change in x is 1 only, but change in y is 3, which is quotient value. For every 1 unit change in the x, how much the y will change means it depends on the quotient value. How much is the quotient value? It will change that much. That is nothing but slope m is equal to y2 minus y1 divided by x2 minus x1. If x2 minus x1 is 1, y2 minus y1 is equal to m only. Change in y is nothing but m only. Nothing but that one only, mathematical equation. If your x2 minus x1 is equal to 1, your slope is equal to delta y. Slope is nothing but delta y divided by delta x only. Na? You know this one, or I have to explain slope? Right? So just, this is mathematical representation, just in order to understand, for every unit change in the x, the y will change with respect to the quotient value. So here, if you see here, that is the inference I have written, that if you are changing the x value with 1 unit, the increase in the TV is associated is with respect to 0.045 units. And if you are working, for example, $1,000 you are investing, for every $1,000 on the TV, you can expect 45 more units will be sold. If you increase the $1,000 on the radio, 188 will be sold. Now, whatever the extra amount is there, he is going to invest that extra amount on the radio instead of on the TV. Is that clear? So here, whatever the 45, for every $1,000, 45. What is the 45 means? Here, whatever the value is there. What is the slope quotient values? So this is the quotient values. For every $1,000, 1,000 into 0.044, which is nothing but 44 units. 1,000 into 0.202 means 202 units. Just you have to multiply 1,000 into the slope. Whatever the quotient value is there, that one. For every $1,000 increment in the x, change in the x is 1,000 means change in the y will be with respect to this much. Got it? This quotient is nothing but, this is the TV quotient, na? That is clear. TV coefficient, which is nothing but slope. Slope is nothing but delta change in y divided by delta change in the x. Now, TV, whatever the quotient value is there, 0.044 is equal to change in y, which is in the change in the sales. How much change in the sales only I want? That is change in the sales divided by change in the amount. I am increasing $1,000. Just you are multiplying 1,000 into that one. The change in y is nothing but, your change in y is nothing but m into delta x. Quotient into delta x. How much change in the x variable is there into the quotient is gives the change in the y variable. Slope meaning is that one. Is that clear? That's it. That is MLR. Now, whatever we have applied, this is MLR, that is TV, radio, newspaper. Now for TV, radio, newspaper, what is the accuracy I have got if I apply MLR? Train accuracy is 90%. Test accuracy is 86%. CV is 88%. And assumptions, one of the assumptions has failed. And based on the assumption, we have deleted the newspaper column also. And we are going with respect to, if you want to apply MLR technique, you have to take only TV and radio. You should not consider the newspaper. This is the final conclusion.